Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, we are from Team 1, Group 2. Here we will presentation our material. The title is Respiratory System, but let me introduce myself and my partner before. My name is Ardadria Pramesti and my partner is Alvina Febilioni, Novidian, and Iriana Anatasari.
The main job of the lungs is gas exchange, pulling oxygen into the body and getting rid of carbon dioxide. Normally, during an inhale, the diaphragm contracts to pull downward and chest muscles contract to pull open the chest, which helps suck in air like a vacuum. And then during an exhale, the muscles relax, allowing the lungs to spring back to their normal size, pushing that air out. When you breathe in, air flows through the nostrils and enters the nasal cavity, which is lined by cells that release mucus. That mucus is salty, sticky, and contains lysozymes, which are enzymes that help kill bacteria. Nose hairs at the entrance of the nasal cavity get coated with that mucus and are able to trap large particles of dust and pollen as well as bacteria, forming tiny clumps of boogers. The nasal cavity is connected to four sinus, which are air-filled space inside the bones that surround the nose. There's the frontal, ethmoid, sphenoid, and maxillary sinus. The paranasal sinus helps the inspired air to circulate for a bit so it has time to get warm and moist. The paranasal sinus also acts like tiny echo chambers that help amplify the sound of your voice, which is why you sound so different when they are clogged with mucus during a cold.
So the relatively clean, warm, and moist air goes from the nasal cavity into the pharynx, or throat. The region connecting the two is called the nasopharynx, and the part connecting the pharynx to the oral cavity is called the oropharynx. The soft palate, the softer portion of the roof or of your mouth behind the hard part that you can feel with your tongue, and the pendulum like uvula hinging at its end move together to form a flap or valve that close the nasopharynx off when you eat to prevent food from going up to in the nasopharynx. Finally, there is the larynxopharynx, the part of the pharynx that continues with the larynx or the voice box. Up to this point, food and air share a common path. But at the top of the larynx sits a spoon-shaped flap or cartilage called the epiglottis, which act like lid that seal the airway of when you are eating, so that the food can only go one way down the esophagus and toward the stomach. If anything other than air enters the larynx, then there's a cold reflex to kick it right out. Now, once air makes its way into the larynx, it then continues down as the trachea or the wide pipe, which split into the two mainstream bronchi. The point at which they split is called the carina. They then enter the lungs, and the right lung has three lobes: upper lobe, middle lobe, and lower lobe. And the left lung has just an upper lobe and lower lobe. The right mainstream bronchus is wider and more vertical than the left, which is why if you accidentally inhale something big that can get caught into like a peanut, then it's more likely to go into the right lungs than the left. The mainstream bronchi, the divide into smaller and smaller bronchi. The trachea and the first three generations of bronchi are all pretty wide and use cartilage for support.
Taking a look at a cross-section chunk, there's also a layer of smooth muscle which has nerves of the autonomic nervous system within it. The autonomic nervous system is made up of two basic types of nerves: synthetic nerves, which are involved in fight or flight, the like running from a turkey, and parasympathetic nerves, which are involved in the rest and digest model, like eating ice cream on the beach. Smooth muscle along the trachea and the first few bands of bronchi have beta-2 adrenergic receptors. Going back to that turkey, when you're running, the synthetic nerves stimulate those beta-2 adrenergic receptors and increase the diameter of the airways. But thus some airways also have muscarinic receptors which can get stimulated by parasympathetic nerves, causing a decrease in the diameter of airways. The large airways are lined mostly by ciliate columnar cells and a handful of goblet cells, which get their name from looking like a wine goblet or glass and secrete mucus. That mucus helps trap particles, and then the ciliate columnar cells beat rhythmically together to move the mucus and any trapped particles from the air towards the pharynx, where they can either be spit out or swallowed. This mechanism is known as the mucociliary escalator. After the first three generations of bronchi, however, the airways become more narrow, called bronchioles, little bronchi, and thus can stay open without the need for cartilage. Air is conducted through smaller and smaller branches for about 15 under 20 generations, and collectively they're known as conducting bronchioles. Now the walls of the conducting bronchioles are similarly lined by ciliate columnar cells and mucus-secreting goblet cells, as well as a new cell type called club cell because they look like chili clubs. These club cells secrete glycosaminoglycans, which is a material that protects the bronchiolar epithelium. These guys can transform into ciliate columnar cells, so they help regenerate and replace damaged ciliate columnar epithelial cells if needed. These conducting bronchioles receive oxygen blood from the bronchial arteries.
The last part of the conducting bronchioles are the terminal bronchioles, and then after that air gets to the respiratory bronchioles, which are unique because they have tiny outpouchings that butt off of their walls. These outpouchings are called alveoli, and there are about 500 million of them within the lung. Eventually, the respiratory bronchioles end when there is nothing but alveoli, and at that point the airway is called an alveolar duct rather than a respiratory bronchiole. This is the final destination of the inhaled air. The alveolar wall has a completely different structure from the bronchioles. They are not cilia or smooth muscle, and instead the wall is lined by thin epithelial cells called pneumocytes. Most are regular pneumocytes called type 1 pneumocyte, but some called type 2 pneumocyte have the ability to secrete a substance called surfactant, which helps decrease the surface tension within the alveoli and keeps them open. Like the club cell, the type 2 pneumocytes are capable of transforming into type 1 pneumocytes, so they can also help regenerate and replace damaged cells. Finally, if a tiny particle ever makes it deep into the lungs, they are alveolar macroplaques that can gobble to up then physically move up to the conducting bronchioles where they can ride the mucociliary escalator all the way up to the pharynx to be either coughed up or swallowed down. Free from particles, the inhaled air is now in the alveolus surrounded by mostly type 1 pneumocytes. On the other side of the pneumocyte are additional cells that line the capillary wall with air where that twisted blood is. This time, cells the blood come from the pulmonary arteries carrying deoxygenated blood. The pneumocyte and the capillaries are glued together with a protein layer called basement membrane. So the alveolar wall, the basement membrane, and the capillary wall is really that separates the air from the blood, and this is called the blood-gas barrier. At this point, carbon dioxide diffuses out from the oxygenated blood and into the air of the alveoli, which then gets breathed out. And with each breath in, oxygen enters the alveoli and freely diffuses into the blood. That firstly oxygenated blood the heads of the pulmonary veins, the heart, and then to the body tissues. Alright, as a quick recap, the respiratory system facilitates gas exchange. Oxygen in the air is inhaled and makes its way through the pharynx, larynx, trachea, legs of airways, conducting bronchioles, respiratory bronchioles, the alveoli, and finally the capillary to be sent to the body tissue. Then carbon dioxide makes the reverse journey to eventually be exhaled into the world.
Okay guys, thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.